Let's continue with this our lecture series on NEET PYQ, right? Today we will start with our next chapter. Our next chapter is laws of motion, right? Let's start with first question. The question says a truck is stationary and has a bob suspended by a light string in a frame attached to the truck. Okay, the truck suddenly moves to the right with an acceleration of a. The pendulum will tilt in which direction? Okay, let me explain you this question with a very simple language. Let's say this is a cabin of a train, right? And inside this cabin there is a small piece of stone hanging over here, in case if you are not familiar with that. Okay, so this truck all of a sudden moves in this direction with some acceleration a. The thing is, you have to find what will be the angle in which this stone will go on the left hand side, right? Okay, so let me draw this properly so that we can figure out that. So let me draw it here. First of all, let's say this is the ceiling of that cabin of the truck. Okay, and here we have a bob attached in this direction, and all of a sudden the truck moves on the right hand side with an acceleration a, and because of that this will have a pseudo force will be acting in the opposite direction and it will tilt in this direction, right? So if the truck is moving on the right hand side with acceleration a in the opposite direction, here this will be mass times a in this particular direction, right? So this will be mass times acceleration in the opposite direction, right? And here we will have an angle theta that they are asking, or this is theta we are looking for, right? So this is the angle at we have to find in this particular scenario. Now the bob will have weight in this direction mg, correct? And because it is tied to a string, there will be some tension in the string, that is T, in this direction, right? Now if we make our axis, this is our y-axis, this is our x-axis, right? So if this is theta, we know that this will be obviously theta, and in this direction the tension will make a component T cos theta, correct? And in this direction it will be T sin theta. Now we can equate here T sin theta equals to how much? MA, correct? That will be equalized, and T cos theta will be equalized with mg. I hope this is clear. Mg, the weight. T cos theta is equalizing the weight of this bob, and T sin theta is equalizing MA, the pseudo force. Now if we divide both of them, this will give us tan theta, and this tan theta will be equals to how much? A by g. So theta here will be equals to tan inverse A by g on the left hand side, right? So theta will be on the left hand side because the truck is moving on the right hand side, and angle is tan inverse A by g. Let's see our options. So correct option in this particular question will be to the left, and the angle of inclination of the pendulum is tan inverse A by g. Be very careful, you are given with sine inverse also. So sine inverse A by g is not correct. The correct answer is tan inverse A by g. So we have option B as our correct answer in this particular scenario. Let's see the next question from PYQ series on laws of motion. Okay, a balloon with mass m is descending down with an acceleration a, okay, where a is less than acceleration due to gravity. The question is saying how much mass should be removed from it so that it starts moving up in an acceleration a. Let me explain you the whole scenario. I hope you have seen a balloon, okay, that hot air balloon. So this is a balloon, not your simple balloon, okay? Just assume it is a hot air balloon, and there are many people which are there on this balloon, okay? And because the weight is a lot, it is going down with some constant acceleration a, and that is less than g, okay? So if this is a balloon, let's see what are the forces acting on it. One is the weight, which is acting downward. One is buoyant force, which is making it go up, okay? If the weight is a lot, it will go down. If the buoyant force is a lot, it will go up. Clear it is? The whole scenario here is because of weight and buoyant force. Clear it is? So let's see in this particular situation. Let's consider the first situation. A balloon with mass m is descending down with an acceleration a. So if it is descending down, the weight is a lot. So weight here is W minus the buoyant force will give it mass times acceleration of this balloon. I hope this is clear. This is our first equation. Let me explain you once again. If the weight is more than the buoyant force, it will obviously go down. If the buoyant force is more than the weight, then it will go up. Clear? Okay. So weight is how much? Sir, weight here will be mg. The mass which is there here minus the buoyant force will be equals to ma. Let's take this ma on that side. It will be mg minus ma, that is equals to the buoyant force. Our equation 1 is this one. This is our buoyant force, right? Okay. Now the problem says how much mass should be removed from it so that it starts moving up with an acceleration A. So how much mass can we throw out, or how many people we can send to the ground so that it starts moving in the upward direction? So let's assume that the mass removed is m dash. Okay, this is our m dash. Now this is the new mass. Now be very careful. Okay, they are asking the amount of mass removed. I am assuming the new mass is m dash. Otherwise, you will have to take it m minus m dash and solve it. Okay, better is I am just taking it m dash. M dash is what? The new mass after removing that people. Let's assume that there were 10 people in this case. Now we removed 2 people. Okay, so how many left here? 8. Now I am dealing with these 8 people here. 8 people here is our m dash, our new mass. But the question is not asking how many are new. The question is asking how many people you removed. 2 people, right? So I am repeating the whole scenario once again. If there were 10 people, I told 2 people to just wait for the next chance. Okay, and we'll take 8 people. So here this m dash is 8, and because of this 8 it is going up, and 2 people I have removed. Question is asking how many people is removed or how much mass is removed. So m dash is not the mass removed. What will be the mass removed? M minus m dash. Correct? M was the previous mass, m dash is the new mass. So you have to be little careful with that. So let's assume that because of this m dash, the balloon is started moving in the upward direction, right? Which means, which one is greater, the buoyant force or the weight? So if it is going up, buoyant force has to be greater than the weight. So now in the second scenario, when it is moving with up with an acceleration A, buoyant force is greater than the weight. And now what is the weight at this time? Because this time the mass is m dash, it will be m dash g will be equals to m dash A. I hope this is clear. Fb minus m dash g is equals to m dash A. Now here, FB, do we know the value of FB? Yes, of course, from equation 1, right? So let's substitute here. It will be mg minus ma will be equals to minus mg, m dash g equals to m dash a. I hope this is clear. Now, let's take this on the other side. So m I am taking here. It will be g minus a, m dash a plus m dash g. Correct? I just took this m dash g on the other side. We have to find m dash. So let's take here common, m dash taking common, here it will be a plus g, and on the left hand side it will be m into g minus a. Now let's take a plus g on the left hand side, it will be g minus a upon a plus g. Many people, they think that this is our answer, right? Okay, many of the students, they think this is the answer. Let me repeat again. I have already explained you before. You can watch it again. Otherwise, I'm again repeating this, that m dash is the new mass which is there on the balloon. But question is asking what is the amount of mass we have to remove. So for that, we have to subtract this new mass and the older mass. So it will be m minus m dash. That will be our final result, the mass we are looking for. So m minus, what is our m dash? It will be m into g minus a whole divided by g plus a, or a plus g, you can make it. Let's cross multiply. So this will be mg plus ma minus mg and minus minus plus ma. Be very careful, whole divided by g plus a. Let me repeat again. I multiplied m with g, mg, m with a, ma, minus mg minus minus plus ma. Let's cancel out what is getting cancelled. Correct? Ma plus ma. 2 times ma whole divided by a plus g or g plus a. This is our final result. This is the amount of mass we have to remove, which is option A. I hope this is clear. Okay. Majority of people, they get confused with this part because they find the new mass. We are not looking for the new mass. We are looking for the amount of mass removed, right? Let's see the next problem. Great. Our next problem says a man of 50 kg mass is standing on a gravity-free space. So there is no acceleration here at a height of 10 meter above the floor. So let's assume that this is our floor, and above this floor here a person is standing. Great. And this person is of mass how much? 50 kg. Okay, fine. He throws a stone of mass. So let's say this is our stone here. And this stone is of 0.5 kg. He is throwing it downward with a speed of 2 meter per second. Okay, fine. When the stone reaches the floor, the distance of the man above the floor will be how much, right? We know that if there is no acceleration due to gravity, the person will have an impact in the upward direction that we have to find, right? Okay. So if we are throwing the stone downward, because of that, An equal and opposite reaction upward will be there, right, to conserve the momentum. So if we conserve the momentum, m1 v1, what is m1? Mass of the stone. Velocity of the stone should be equals to m2 v2. What is our m2? Mass of that person, and v2 the velocity it will acquire while going up. It's a gravity free zone. Okay, so there is no acceleration. So what is m1? Mass of the stone. Mass of the stone is 0.5 kg, and what's the velocity? 2. Mass of this person 50, and what's the velocity of this person? v2. Let's take 50 on the other side. So 0.5 into 2 whole divided by 50, that's our v2. What's 0.5 into 2? Sir, it's 1. So 1 over 50, that's our v2, our velocity of this person. Correct? Velocity of this person is 1 over 50. I hope this is clear. Okay, 1 upon 50 meter per second, you can write unit if you want to. Okay, the question says when the stone reaches the floor, the distance of the man above the floor. Now the question is, sir, when our stone reaches the floor, this is the velocity with which the person is going up. But the thing is, we don't know when the stone is reaching at the floor. To find that, we will simply use the concept of speed equals to distance over time. Sir, why you are not using the equation of motion? Because acceleration is not there, right? So we can find the time t is equals to distance upon speed. How much is the distance? So distance is given 10 meter. As per the problem, it is 10 meter, right? And how much is the speed of the stone? So speed of the stone is 2. So time taken by the stone to reach up the ground or the floor is 5 seconds. In that 5 seconds, how much the person will go up? So for that, we have to find the distance traveled by the person, and that will be from the same formula, speed into time. What's the speed of the person while going up? Sir, it's 1 by 50. Sir, it's not given. Yes, we found it, 1 by 50. That's the velocity or the speed of the person while going up. And what is the time? Time taken will be 5 seconds because they are asking in that particular time interval. So it will be 1 by 10, and that's 0.1. Okay, clear it is. Now this is 0.1. This distance is from what? From this point, because it was already on the top of this building or this particular height, 10 meter. Okay, so it was 0.1 meter above this particular. So from floor, question is asking the distance of the man above the floor. Above the floor, it will be 10 and 0.1, and that will be how much? 10.1. So correct answer is 10.1. Okay, 10 meter the building is there, or 10 meter the particular that floor is there from the ground floor, and he is going 0.1 up. So 10 plus 0.1, which is 10.1. I hope this is clear. Let's see the next problem. Okay, simple straightforward problem, and you will find it simple only if you know vectors. If you are not familiar with vectors and you have directly jumped here, please go through the previous videos. Okay, I have already uploaded, and you will find the playlist link in the description. So I'll come back here. A body under the action of force F is how much? Our F is nothing but 6I minus 8J plus 10 kg. Correct? Acquires an acceleration of A equals to 1 meter per second square. The mass of this body must be how much? Yes, we have to find the mass. Okay, now the many students, they'll do, sir, directly divide F by A, you will get the mass. Be very careful. Mass is a what? Scalar or vector? It's a scalar quantity, right? You can't have I, J, K. So first let's figure out the magnitude of force. So our magnitude of force will be root under 6 square 36. Magnitude of this 8 square will be 64. 10 square will be 100. Correct? So this will give you root under 200. Correct? And that will be 10 root 2. So 10 root 2 is our force. A is 1. So now we can find F equals to magnitude of force by magnitude of acceleration. If acceleration was given in vector, in that case also we will convert it into magnitude, right? So what's our force here? 10 root 2 upon that. So that will be our 10 root 2 kg. That's our mass. Clear? Now many people will say, sir, it's equal to force. No, be very careful. Acceleration here is 1. So that's why we are getting mass is equals to the force. Understood? I hope this is clear. Quite easy problem. Let's see the next one. Okay, coming back to our next question. A block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that the block does not slip on the wedge. Okay, the force exerted by the wedge on the block, G is acceleration due to gravity, will be how much? Okay, quite simple problem and very common problem from pseudo force concept. Okay, so focus here. This is a wedge. Okay, this is a wedge, and what's the inclination of this wedge? Sir, inclination of this wedge is theta. You're placing a block over here. Okay, this is our block in this case, and this wedge is having, or we are applying an acceleration in the forward direction. Okay, because of that, this block is not slipping down. Let me repeat again. You are applying some force. Because of that, the consequence of that force is there is an acceleration in the front direction, and that acceleration is making this block to stay here. It is not allowing this block to go down, right? Great. Let's see the forces acting on it. Okay, so let me just draw the directions of force. Let me just draw the directions of force. Our force here is, one is weight of this block which is acting downward. I hope you have done inclined plane. You will be familiar with that. If this is mg, what is the force which is making this block to go down? Sir, mg sine theta, right? Mg sine theta is making it down. And where will be mg cos theta? Sir, mg cos theta will be in this direction, so it will be mg cos theta. I hope this is clear. And where will be normal reactions? A normal reaction perpendicular here, n or r, whatever your teacher use it. Okay, I'm using n is normal reaction, or you can use it as r also, doesn't make any difference. Okay, along with this, there are other set of our forces. The pseudo force which is making it, okay, the acceleration is in this direction, so pseudo force will be acting on this block. Okay, this will be in this direction, so F equals to, this is the F. Okay, and if you split its component, okay, here it will be F cos theta. F cos theta. Sir, how you got F cos theta there and not F sin theta? That can be one question, right? So if this is theta, we are already familiar that this will be angle theta, right? This will be our angle theta. We already know this. Okay, inclined plane concept. Okay, mg cos theta, mg sin theta. Okay, fine. If this is theta, correct, and this is theta, this will be how much? This will be 90 minus theta, correct? This will be 90 minus theta, and if this is 90 minus theta, this will be again theta. Okay, and if that is theta, then that component will be F cos theta. Now, if we focus here on FBD, we know that normal reaction is equalizing the mg cos theta, correct? If normal reaction is equalizing mg cos theta, then what is equalizing this mg sin theta? F cos theta. So I'm just writing here F cos theta is equals to mg sin theta, correct? And if we take this cos theta on the other side, it F, the force, which will be equals to mg sin theta whole divided by cos theta, or you can say mg tan theta. So here straight away they have given mg sin theta upon cos theta. That's our correct answer. Clear it is? So where did this F sin theta go? F sin theta will also go in this particular direction. Okay, so normal reaction in this particular case will equalize two forces, mg cos theta and F sin theta. I hope this is clear. Okay, just to avoid any other confusion, let's see the next one. Great. An object of mass, so question here is giving you m equal to 3 kg, is at rest. So initial velocity is 0, fine. If a force of F equals to 60 square I cap plus 4t j cap Newton is applied on the object, then the velocity of the object at t equal to 3 seconds. We have to find that. Okay. To find velocity, we need acceleration, right? Acceleration we have to find. So acceleration A will be straight away F by m. So here why you are not finding the magnitude? You are not finding the magnitude because acceleration is a vector quantity. We know that. So straight away we can get it in terms of I and j. So what is F? This. And what is m? 3 kg. So let's divide it. 60 square I cap 4t j cap whole divided by 3. So this will give us 2t square I cap plus 4 by 3t j cap. I hope this is clear. This is our acceleration. If you are given with acceleration, you can find the velocity. How? By integrating it. So where we learned it in the previous lectures. If you have not watched it, link is in the description. Again, I'm reminding you, but these are from kinematics, right? So there you can see, go through it. There you will learn it, that velocity will be nothing but integration of a dt. Correct? There we have discussed and done some PYQs on the same. So here it will be 2t square I cap plus 4 by 3 t j cap dt. Okay, let me just keep it in bracket. Now, on integrating this will be how much? And time limit is 0 to 3 seconds because it started from our that thing. Initial velocity was 0, so 0 to 3. Okay, in that case, this will give you 2 outside. And what is t square integration? So it will be t cube by 3. I am taking 2 as constant out of the integration. I hope you are familiar with integration. T square will give you t cube by 3, and that will be 0 to 3 I cap. Taking 4 by 3 outside, integration of t will be t square by 2, 0 to 3. Correct? I hope this is clear. And where's j cap? Yes, j cap is over here. Let's substitute here. So this will be 2 into 3 3s are 9 3s are 27. 27 by 3 is 9. So it will be 9 minus 0. So I'm just keeping it as 9. Okay, I'm not explaining this part. We have already done many problems in the previous lectures, right? Plus 4 by 3. 3 3s are 9. So 9 by 2 minus 0 by 2 j cap. Let's simplify it further. 2 9s are 18 j cap. Oh, sorry, I cap, not j cap. So 18 I cap, 18 I cap, and 3 3s are 2 2s are. So 2 3s are 6 j cap. That's our velocity for this particular particle at t equal to 3 seconds. So 18I plus 6j. Is there any option? Yeah, option B is correct in this particular problem. 18I plus 6j. Let's see the next one. Great. Let's see the next one. The next one says a player takes 0.1 second. So time here is 0.1 second. In catching a ball of mass here is 150 grams. Let's convert here straight away into kgs, 10 to the power minus 3 kgs. Moving with the velocity, v here is how much? 20 meter per second. The force imparted by the ball on the hands of the player. The force imparted by the ball on the hands of that player. The force is nothing but change in momentum, mv minus mu by t. Okay, that you have to find. Clear? Now that in this case, final velocity is 0. So straight away f, they are saying the magnitude. So we can ignore the negative sign. M is how much? M is 150 into 10 to the power minus 3. Velocity of the particle is how much? 20 meter per second upon time is 0.1. Let me remind you once again, the force imparted by the ball on the hands of the player will be this much. It will be positive, taken here as positive. Okay, or the force by action reaction pair, it will be negative from hands on the ball. So this will be how much? Point removing this, you will get 10 here. 1 0 2 0 3 0 10 to the power minus 3 went, and that will be 15 to the 30 Newton. That's our correct answer, option C. Direct simple class 9th problem. Okay, but it was a PYQ. Okay, it was a PYQ. In case if you have any book on PYQ, you can confirm. Okay, let's see the next one. Great. The force on a rocket moving with the velocity. What's the velocity of the rocket? 300 meter per second. Great. And what's the force? So force is 210 Newton. Okay, beautiful problem. The rate of consumption of fuel of the rocket. So in case if you have done rocket problems previously, you are familiar with the relation F equals to V dm by dt. Where this happens or where we use this relation? In case of rocket problems, right? So force is equals to V dm by dt, or wherever there is a change in mass, right? Okay, we will see some problems more other than rocket where we use this particular equation. So F is the force given as 210, V is the velocity with which the rocket is moving, and dm by dt is the rate of change of mass, which means the combustion of fuel. Okay, 300 taking on the other side, 210 upon 300, that will be equals to dm by dt in this case. 0 and 0 cancel, 7 3 we can cancel out, 3 sevens are and 3 tens are. So it will be 0.7 kg per second. This much amount of fuel is burnt per second. So 0.7 kg per second. Is there such answer? Yes, option A is there. Be very careful. Option A and C look similar, but its correct answer is A. Let's see the next problem. A 5000 kg rocket. So mass of the rocket here is 5000. Is set for vertical firing. The exhaust speed, VE means exhaust speed, I am assuming 800 meter per second. To give it an initial upward acceleration. Now upward acceleration is there, which means it is overcoming the acceleration due to gravity, 20 meter per second square. The amount of gas ejected per second to supply the needed thrust will be, so G here is 10 meter per second. What they are asking? They are asking dm by dt. This is the amount of fuel burnt or gas ejected per second, dm, or if fuel will be burnt, then only there will be gas ejected. So dm by dt you have to find. Okay, let's see this scenario. If this is a rocket, okay, and it is set as vertical firing, okay, in the vertical direction, then here what are the forces? Okay, what are the forces here? The forces here will be, downward direction will be weight mg of the rocket. Correct? It is downward direction. What is the weight? Downward direction, it is the weight mg. and it is going up with some acceleration, so ma, correct. And one equation that is responsible for burning of fuel, so burning of fuel is what, v dm by dt. Clear it is? Okay, I hope this is clear. So this is making it go up, this is making it go down, and this is the resultant one. So what is making it go up? V dm by dt. So I can say V dm by dt. This is making the rocket to go up, overcoming the weight, which is minus mg, and that is giving you m times a, mass times acceleration in the rocket. I hope this is clear. You got the equation? Let me explain you once again. This is something which is making it go up. The fuel is burnt and making it go up. This is something which pulling it down, the weight. And when it overcomes this, then only there will be resultant mass times acceleration in the rocket, right? So what is our m? So m is 5000. What is our acceleration of the rocket? Sir, acceleration is given here, 20. What is our velocity of the rocket? Sorry, velocity of the exhaust, you can say, dm by dt minus the mass, which is 5000, and I am assuming acceleration due to gravity as 10. They have given, yeah, g equal to take 10. Okay, so this will be 5 2s are 10. Okay, and how many zeros? 1 2 3 and one more 4. 4 zeros and 2 5s are 10, correct. And I am taking this on the other side, so this will be plus 5 and how many zeros? 4 zeros. This will be equals to 800 dm by dt. I hope this is clear. Now this will give you 4 zeros and 15, and after that 4 zeros, and taking 800 here, it will be below it, so 800. Be very careful with the zeros. Okay, decimals you have to be very careful. Let's cancel out this with this, this with this. So we left with 1500 divided by 8. Let's divide it directly. 8 2s are 16, so 8 1s are 8. 70, 70 means 8 9s are 72, so 8 8s are 64, correct. So 70 means 60 you left with, so 60 means 8 7s are, and that will be approximately 187.5 kgs per second. That's our correct answer, dm by dt. I hope this is clear. Option B is correct. Clear? So you have to be very careful with this particular thing. What is making the rocket go up, what is pulling it down, and what will be the resultant, right? Let's see the next problem. Great. Our next problem says a force of 10 Newton. F here is how much? 10 Newton. Is applied on a body, produces an acceleration. What's our acceleration? Sir, acceleration is 1 meter per second square. The mass of the body. Now this kind of problem they can ask you even in 6th or 7th standard. You can do it, okay, but this was PYQ. So F equals to mass times acceleration, right? So m equals to F by a, and what is our force? 10. Acceleration is 1, so mass will be 10 kg straight away. Clear it is? Okay, let's see the next question. Great. If the force on a rocket moving with the velocity, what is our velocity of rocket is 300 meter per second, and force is how much? 345 Newton. Then the rate of combustion of fuel, dm by dt they are looking for, right? And we have already done 2 or 3 problems on that, so now you can solve it easily. I'm doing it for you very fast. F equals to v dm by dt, and F is nothing but 300, v is nothing but 345. Straight away we can put it down here, and we're left with dm by dt, correct. Let's simplify it further. Let's cancel out 3 hundreds, 3 ones, and this will be how much? Or I did opposite. Yes, I did opposite. It's F is 345 and not that. So you have to be very careful when you are fast. F is 345 and V is 300. I did opposite, huh? So that will be equals to dm by dt, and this will be, we can cancel out with 3, it will be 100, it will be 3 ones are 3, 3 ones are 3, and 5, so it will be 1.15 kg per second. That will be equals to dm by dt. I hope this is clear. Very simple, straightforward question. 1.15. Clear? Let's see our next question. Great. Many students, they get confused with this straightforward and very simple problem. Let's see here. A satellite in a force-free space sweeps stationary interplanetary dust at a rate of dm by dt, which is given straight away. Dm by dt is how much? That will be equal. So if it is sweeping it, it will be alpha v, correct? Now they are saying the acceleration of the satellite. If it is sweeping something, the acceleration will be, the force will be, okay, retarding force here, or you can say F will be equals to minus m v dm by dt, correct? Okay, minus v dm by dt. And what is our dm by dt? It's alpha v. So straight away minus v alpha v. So that will be how much? Minus alpha v square. But they are not asking the force, they are asking the acceleration. So we can write here by Newton's second law, F equals to ma, and acceleration will be equals to minus alpha v square by m. Straightforward, simple problem. Okay, minus alpha v square by m, that's option B. I hope this is clear, right? Simple. Okay, only students, they get confused by looking at such equations. Okay, let's see the next one. Okay, great. Let's come back to the rocket one. A 600 kg rocket, so mass here is 600 kg, is set for vertical firing if the exhaust speed v equals to 1000 meter per second, the mass of the gas ejected per second to supply the thrust. Direct, straight away, F equals to v dm by dt. And what will be your dm by dt, sir? It will be F by v. And what is our F, sir? F is nothing but, oh, F is not given. We are given with thrust to overcome the weight. Okay, so see, such a big difference. Here we are overcoming the weight. So here this F is equals to mg. Be very careful here. So F equals to mg in this case, and now we can find dm by dt, that is equals to mg upon v in this case, right? Because it's just overcoming the weight. So m here is, what is the mass of the rocket? 600, and acceleration due to gravity is 10, I am assuming, and velocity here is how much? 1000. So this will give us 6 kg per second. Let's see if there is any such result. Yes, option C is correct. 6 kg per second. That is the amount of fuel burnt in this case, right? Let's see our last problem for today. Great. A ball of mass m is how much? 0.15 kg is dropped from a height of 10 meters. So h is equals to 10 meter. Fine. Strikes the ground and rebounds to the same height. The magnitude of impulse imparted will be how much? Okay, let me explain you what is happening here. We have a ball which is going down, okay, from 10 meters, and it is going and hitting the surface, and because it is going and hitting the surface, it is rebounding and coming back to the same height. Okay. Now, if it is falling down, what is the velocity with which it will hit here? That will be equals to under root 2gh. Yes, we have done this in the previous chapters. So, velocity with which the ball will go and hit here will be under root 2gh. And after hitting, it will go up back. Yeah. So, if it is going back to the same height, it should have the same velocity. Great. So, if the velocity is same, logically, sir, the momentum change or the imparted impulse will be 0. No, you have to be very careful. When it is going down, it has a velocity v1. But it is going up, it has a minus v1. Or you can call it as v instead of v1 putting, because we don't require any suffix here. So, if the velocity going down is v, the up it will be minus v. So, while going down, its momentum will be mv. While going up, its momentum will be minus mv. Sir, from where you got this negative? Because it is going upward in direction. So if it is minus mv, the change in momentum is the impulse imparted in this case. So delta p will be equals to how much? P1 minus P2 or P2 minus P1 you can do. And that will be equals to mv minus minus plus mv. That will be equals to 2 times mv. Correct? Beautiful. So if it is 2 mv, impulse imparted will be equals to 2 times m into under root 2gh. So from where you got this root 2gh? Again, I'm repeating, if you have not seen our previous lectures on kinematics, they are there in the playlist. In the playlist has a link in the description, so you can watch it. Okay, so here it will be 2. What's our mass? It's 0.15, and it will be root under 2 into g. I'm assuming 10, and h here is again 10, right? So this will give us 0.15 into 2, that's 0.3, and 10 coming out, and root 2. 10 into this will be 3 root 2, and 3 root 2, which is 3 into 1.41, okay, 4. So that will give you approximately 4.2, okay, kg meter per second. That's our impulse imparted. Clear it is? So you have to be very careful in such scenario when the option is 0 also there, but 0 is not correct. Okay, why 0 not correct? Because of the direction change in the velocity. I hope you understood this. Okay, if you have any suggestions, you can put it in the comment. Otherwise, you can watch other lectures also, which are there in the description. We'll continue in the next lecture.